Hello, my name is Doug McDonald. I'm from Al-Attiyah, part of the GE Vernova Company Group, and I'm glad to be here today with Al-Attiyah Group to talk about how nuclear plays a major role in achieving net zero. Nuclear is very critical to achieving net zero. At GE Vernova, we have many aspects that play into that. One is on wind and solar. We have some of the most efficient and largest wind turbines in the world. Those will continue to play a large role in decarbonizing the energy mix over the next 10 to 15 years. Also, our gas power business is doing a lot of innovation to reduce the amount of carbon they produce. In today's solution, we need quick deployed, deployable, low carbon assets. Gas is a good product of gas. Also looking very strongly at storage and hybrid solutions. And one thing we can absolutely take the point of having batteries that can do multiple weeks of storage. Today, we can do a little bit of daily storage and supporting renewables needs. But there is also storage, which has been around for decades. Renewable plays a part in it, which can actually do weeks and sometimes even longer amounts of storage, depending on exactly what the conditions were and how the electric dam based. Come back to nuclear in just a minute. The grid is also a very important thing. First of all, we need the grid to be able to move energy from where it's produced to where it's consumed. Also, as we look at the grid, energy that is not transmitted, that is lost from transmission, is just wasted from it. We really minimize the losses in the grid, how we maximize efficiency, maximize the time of the grid. And then wrapped around everything is our digital technologies, looking to improve from a particular source, your overall energy mixes, or individual components, helping to make sure that they don't fail when you don't expect them to. And so your power plants, your grid, always there as expected. But I will spend a little bit of time looking at nuclear. Nuclear will continue to play a critical role in achieving net zero. Today, for example, in the United States, it produces about 52% of all carbon-free energy that the United States consumes. This is similar in many parts of the world, but other parts of the world are just beginning the nuclear journey. They expect nuclear to continue to play an important role in decarbonization. Nuclear plays a differentiated and critical role in solving the energy trilemma. About energy trilemma, I'm talking about security, sustainability, and affordability. We need all three to come together, to work together, to make sure we have a carbon-free future. Nuclear provides safe, reliable, baseload, and dispatchable power. Our renewables are very interesting. However, if the wind is not blowing, as the sun is not shining, they can have difficulties providing the energy the world needs to live and produce. Nuclear provides 24/7 dispatchable power. The plants we have online today achieve more than 90% capacity factor. So it's not in the, again, when the wind is blowing, wind can produce nice capacity. However, nuclear provides that high capacity factor 24 hours a day, 7 days a week, all year round. It's very resilient to any type of weather conditions, which we see with hurricanes and other type of natural phenomena, snowstorms, in some areas, sandstorms here, about where I'm talking from today, to cause disruptions in the grid. Nuclear is very resilient to that. Also, in our sustainability aspects, nuclear, once it's built, produces energy in a carbon-free manner. It has a potential not only to produce electrical grids, but drive deep decarbonization as you look at in the industrial process. Production, desalination, as well as direct air capture. Direct air capture is a very interesting technology because it removes carbon and other greenhouse gases from the environment. But it does need energy to drive those. Nuclear can make that drive, as well as the warm water heat that needs to help actually achieve maximum efficiencies in direct air capture. Especially in the affordability standpoint, that's where small modular reactors hold a lot of. These gigawatt scale reactors have produce a large amount of carbon-free energy. However, they become so large that they're no longer really mega projects. They go to giga projects. Small modular reactors are more smaller size, and with that becomes less difficult projects to implement, as well as more overall affordability. Some of our aspects are looking at how do we shorten the construction times, also how do we get to many of the companies, as far as we have driving reproducibility in both use of the design as well as the supply chain. So we're moving a lot of effort out of the field and putting it in for factories where it's reproducible and much more efficient. The Energy Association, and that Energy Association looks at the amount of nuclear power that the world expects to use. We expect tripling or doubling of capacity by 2050 to meet net zero carbon emissions. Earlier today, many of the ministers got together and pledged even more than this to meet their specific needs. Either way you look at it, nuclear has a large role to play. It's an increasing role to play. And by 2050, we expect to have more than 900 gigawatts to build to produce to support a net zero emissions. If I focus in on Al-Attiyah a little bit more closely, we have over 60 years of experience designing, servicing, and developing nuclear power plants. A lot of our effort is on boiling water reactors, which we have a large fleet of today throughout the world. We're also supporting sodium-cooled fast reactors. The top of reactors of TerraPower and Arc Energy of Canada are looking at to produce their nuclear reactor technology. We've been doing that type of work since the 1980s and have taken the part of our nuclear power in the sodium fast reactors and donated them to the TerraPower neutron reactor and the reactor from Canada. The GE's nuclear reactor was actually the first one producing power from the public. We've deployed over 67 reactors in 10 different countries. We also have a very good history, especially our ABWRs, which are large modular reactors, not small, but large modular reactors in Japan, on time and on budget. We have over 60 years of continuous innovation. We have over 6,000, almost 7,000 patents. And we have a worldwide organization looking to achieve the nuclear things. In particular, the BWX-300 is our small modular reactor. It produces approximately 870 megawatts of thermal, or if only electricity production. And this energy produces power electrical generation. It can also power district heating, very important to our friends in Europe and elsewhere in the world. Desalination, very interesting here from Dubai in the broader Middle East, as well as hydrogen production. You hear a lot of interesting things about hydrogen, but seldom you understand how we're going to produce it. Nuclear power provides the opportunity to produce it carbon-free. Also, direct air capture is open to the school. The 300 megawatts is a very common size for a small modular reactor. As we're looking to develop our SMR, small modular reactor, we chose to have a grid scale reactor of approximately 300 megawatts of load. Addition to coal, very interesting size and fits within those of the coal production plants and for business. Things I've talked about so far are important for the environment, but we also need to consider safety. The BWX-300 is world-class safe, and it continues on the very safe aspect of our reactors in the country. One of the things that we drove as we looked at this was using proven known field as commercial developers. We do have a robust supply chain and we're ready for global deployment today as we speak. The BWX-300 uses decades and decades of best practices. And we did a few key innovations to make sure that it was suitable aspects of it. It is a 10th generation, hence the X in the BWX, boiling water reactor. It leverages a lot of information in the licensing within the United States. So it's a big size thing, the ESPW. It uses commercially available food. We have 6,000 bundles already in use in the world today. It does not need inlet fuel, which is one of the interesting things and aspects some of the more advanced reactors with Gen 4 reactors use. This is a Gen 3 plus reactor that is ready to be deployed today. It uses low-enriched fuel as opposed to the it leverages existing supply chains that we are expanding them to meet the demand that we've seen, and it uses many off-the-shelf applications. As our designers, every component, they would look at the requirements, they look at the needs, they look at the safety aspects, and make good choices and to the extent possible, choose items that are already commercially available on the machine. As I mentioned, the innovation was put into it. We changed the way we handle some types of accidents, and we made it more safe and more simple in doing so. On a per megawatt basis, we're using less concrete and steel, a gigawatt size reactor, and it actually has a smaller footprint. Now, it's still not exceptionally small. It still takes about a football field to handle what we call our project, which is our control building, our reactor building, turbine building, and that waste building. Everything that is needed to produce power fits in approximately 50. That does several things for us, but one of the key aspects is increasing the resiliency to unplanned events and actually malicious attacks, whether it be aircraft impacts, simplifications. The global water reactor has been simple since day one, and they continue to simplify. Vitabricks 300 is a natural circulation. We do not need pumps to drive the cooling and water. We need is passive safety systems. We can handle more than 7 days without operator interaction to cope with any type of unexpected event that may happen. And be restored in that 7 days. Simple accident. Going in cool water that's atmospheric conditions is all that's needed. And any source of water, whether it be fire water system, public potable water system, or even seawater could be used to fill those pools through pre-existing connections, which are ready to go when they're needed. Had a lot of success to date with the boiling water reactor, the Vitabricks 300, and we're building momentum for even more. In North America, material power generation is our lead project. In 2002, October, they submitted the license to construct for a Vitabricks 300 of their Darlington Union project station. And then they announced after that they plan to add 3 additional reactors to that site. In Tennessee, in the United States, Tennessee Valley Authority is working on the construction permit application for the Clean Sugar Nuclear plant. We've not decided exactly how many that they'll build there, but the first one is underway, and they expect to submit that application for construction in 2024. At that site, they already have a 30 site permit, which makes work ready to begin when the construction permit is. Going back to Canada, SAS Power is also down selected the Vitabricks 300 for its grid-scale applications and is looking to get underway for early works for this reactor. We have many other U.S. utilities looking to deploy the Vitabricks 300 as they're evaluating the Vitabricks 300 now. And we have very many new entrants into the field, whether it be grid services or web services, they're all coming to us. And it's a little bit different than we used to. In the old days, 5 years ago and before, it was always large utilities, oftentimes state-owned companies. Now we're seeing independent developers. In Estonia, for example, a startup company is actually leading the charge to bring nuclear to Estonia. That's from energy. We've also had many other developers that look to put in the web serving browser or server farm, powered by nuclear power to make sure that their footprints are good. They also have industrials such as steel, aluminum makers. They're looking to green out their production. In Poland, Central Green Energy is doing a great job of bringing energy to Poland that is carbon free. They've gotten the general opinion that the Vitabricks 300 can be built there, and they've looked at 6 sites, which they've submitted the decision of principle for the regulator to consider. In Poland, also, the U.S. Export-Import Bank, as well as the U.S. International Development Finance Corporation, has signed letter of intent to fund up to $4 billion for lending to support the projects in Poland. I mentioned Estonia already with Al-Attiyah. In the United Kingdom, we've submitted our application to enter their general design assessment, as well as we've been down selected amongst several others to enter the Great British Nuclear competition for SMRs. In the Czech Republic and Sweden, we're seeing lots and lots of interest. They're going toward to look at how to bring nuclear power to those countries, to increase nuclear power. But they're looking how do they progress even further? How do they decarbonize? How do they demand they have going in the future and ensure that it's carbon free? And nuclear is coming up the choice time and time again. So those are the points I had for today, and I appreciate your attention. I believe there's a small audience here. I don't think there's any questions in the audience. And so with that, again, I'll say I'm very pleased to be here. Glad to be able to spend some time with you to talk about these points, and wish everybody a great day. And I look forward to get back and enjoying the day after COP 28. Thank you very much. But that, I just